Then moving on to the next topic, that is the scalars and vectors. Scalars and vectors. Now when talking about scalars and vectors, what are these scalars, what are vectors? Now earlier we have discussed what are physical quantities. Now the physical quantities, we have classified them into fundamental quantities as well as the derived quantities. Now whether you are talking about a fundamental quantity or whether you are talking about derived quantity, they come under one particular category. You can classify them as scalars and vectors. In simple terms, we say that the physical quantities, all the physical quantities can be expressed either as scalars or else you can express them as vectors. Now for example, suppose that when I'm talking about a particular term called as length, I'm talking about a particular term called as length. Now this particular term called as length, basically we call it as a fundamental quantity. At the same time, suppose that you're talking about one more quantity called as force. Now this particular quantity called as force, it comes under derived quantities. Now this is a fundamental quantity, this is a derived quantity, but in simple terms we put both these two under one particular category, which we call them as the physical quantities. And these particular physical quantities can be expressed as either scalars or else vectors. First we'll see what is a scalar quantity. Now when talking about the term scalar, what are scalars? Right. So first we'll talk about the term scalars. Now when talking about the scalars, any particular physical quantity which is having only magnitude, that particular physical quantity is known as a scalar quantity. So these particular scalars, they simply have got magnitude, right? At the same time, suppose that if a particular scalar quantity is having both magnitude, at the same time if it is even having certain amount of direction, magnitude along with that it is having direction, so that particular physical quantities we call them as vectors. So vectors possess magnitude as well as direction, but scalars possess only magnitude. Now we'll see the number of examples for this. Now first of all, when talking about the case of scalars, the physical quantities which have only magnitude, you call them as scalar quantities. Now the examples for the scalars, first and foremost thing, you're talking about the case of length. Now the length of a particular object, suppose that this is an object, the length of this object is something around 15 centimeters. If you're placing it in this particular way, the length is 15 centimeters. You place it vertical, it's 15 centimeters. You place it inclined, it's measuring 15 centimeters. Right? So even though the direction of the object is changing, the length of the object will not change. At the same time, you talk about one more physical quantity called as mass. Mass is again a scalar quantity. So the quantities which possess only magnitude, maybe 5, maybe 10, whatever is the units, right? So here when I'm talking about the case of length, I'm talking about 5 meters. When I'm talking about the case of mass, I'm talking about 5 kgs, right? When I'm talking about time, I talk about 5 seconds or else 5 hours, right? Now all these particular physical quantities, they simply have got some numbers, but they do not have any particular direction. So such physical quantities we call them as scalar quantities. At the same time, when talking about the case of vectors, right? So in the case of vectors, right? So in the case of vectors, they possess magnitude, along with that they possess direction. Now for example, suppose that I'm talking about a particular physical quantity which I'm calling it as velocity. Now in order to talk about velocity, we talk about another physical quantity which we call it as displacement. Velocity of an object is equal to the ratio of displacement time or else the change in displacement with respect to time. That is what you call it as velocity. But First we'll see what is displacement. What is displacement, right? Now suppose that you are having two different points, the point A as well as the point B. The point A as well as point B. In order to move from the point A to point B, we can move in one particular way like this, or else we can move in different path like this, or else when you are moving from point A to point B, you can move in different path like this. So when you are moving from point A to point B, we have got altogether three different paths. One, this is the first path, second one, and as well as the third path. Three different paths. But out of these three different paths, the shortest distance between the point A as well as the point B, this is the shortest distance. At the same time, when you are moving from point A to point B, you are moving in a specific direction. Either you are moving towards your left hand side, or else either you are moving towards the right hand side. The shortest distance between 2 points in a specific direction, that is what we call it as displacement, right? So this particular velocity is the ratio of displacement and time. So displacement is defined in terms of shortest distance with respect to shortest distance in a specified direction. So here you are mentioning the direction of an object, in which direction the object is moving. Either the object is moving towards the left hand side, right hand side, or as north, south, east, west. You are mentioning the direction. That is the reason why we say that velocity, right? Velocity is a vector quantity, right? At the same time, displacement is also a vector quantity. Since when talking about displacement, we are saying that the shortest distance between 2 points in a specific direction, that is what we are calling it as displacement. So examples for vectors: displacement, velocity. At the same time, you're talking about one more physical quantity which we call it as acceleration, then force, stress. All these are nothing but your vector quantities. So vectors are the physical quantities which have got magnitude and direction. At the same time, scalars are the physical quantities which possess only magnitudes, right? Now based on these things, we just move on to the next topic, right? So the next topic, coming to the case of the next topic, is kinematics. Now this particular topic called as kinematics, we will just see up to the 10th standards, or else your 9th or 10th standards. We need not work on basically the problems on this one. As long as you're talking about the SSC point of view, we need not discuss about the problems. But the basic info about kinematics is must. So when talking about the case of kinematics, first and foremost thing, what is the meaning of the word kinematics? Right. So when talking about the case of mechanics, we talk about two different words. One is kinematics, the other one is dynamics. Kinematics as well as dynamics, these are the two different branches of mechanics which we'll discuss. Now in the broader sense, when you're talking about the case of kinematics, here in the case of kinematics, we do not discuss the cause of the motion of the object. The cause is not discussed. Why the object is moving from the point A to point B, that is not discussed. Why the object is coming to rest, that is not discussed. Right? The reason for motion of the object, the reason for coming to the rest case, these two things are not discussed. Why the object is coming to motion, why the object is coming to rest, that particular thing is not discussed. We simply talk whether the object is in motion or else whether the object is at rest. That is what is required here. So here the cause is not discussed. But in the case of dynamics, we discuss why the object is moving from point A to point B, under what influence. Right? So whenever a force, suppose that a force of 5 newtons is acting on a body, of certain mass, let the mass be something equal to 10 kgs, right? So when a force of 5 newtons is acting on a body of 10 kgs, it is producing some change in the position of the object, right? So here why the object is moving? Because you are applying certain amount of force. So here we are talking about the reason why the object is moving. Suppose that if an object which is already in motion, right, if you want to stop it, you need to apply certain amount of force. How much force you need to apply? Let's something around 10 newtons or 20 newtons. Again, you're talking about certain amount of force. So when you are mentioning the value, when you are mentioning the force, right? So there in that particular case, you're talking about the topic called as dynamics, right? A branch of science wherein we are talking about the reason why the object is in motion, why the object is coming to rest. That is what you call it as dynamics. Right. Now, in the case of kinematics, the first and the foremost thing that we need to discuss about the basic things, first one is speed. Or else, right. First, we'll talk about what is distance and then what is displacement. First, we'll talk about distance as well as displacement, two physical quantities. Now, when talking about the case of distance, again we'll take the earlier example, the points A as well as B. So when you are moving from point A to point B, this is one path wherein you can move from point A to point B. At the same time, you have got another path. This is the second path. At the same time, you have got one more path wherein you are moving from point A to point B in this particular way. Now, whether you are moving from point A to point B through 1, 2 or 3, ultimately we are reaching the point B, there is no doubt in that. But when talking about the case of distance, the total length of the path that is covered by an object, the total length of the path, the total length, whatever is the object, whatever the object is covering, the total length of the path that is covered, that is what you call it as distance. And this particular distance, the units for distance is always measured in terms of meters, and distance is a scalar quantity, since here we are not talking about the direction of the object, right? The direction of the object is not specified. So when an object is moving from point A to point B, the direction of the object is continuously changing. If you are talking about the path number 3 or as a path number 2, the direction of the object is continuously changing. That is the reason why direction is not specified, right? Now, for example, if I take the case of this one, if I take this particular case, route the path number 3, at this particular point, the object is moving in this particular direction. The moment the object is coming to this particular point, the object is moving like this, right? The moment the object is coming to this particular point, it is moving like this. At this point, moving in the downward direction. Here, it is moving towards the left hand side. Or else at the same time, this point, it is rising up, moving upwards. And finally, it is here moving in this particular way. Which means here in this particular case, the direction of the object is continuously changing. Since the direction is not specified, right? At the same time, here we are talking only about the total length, whether it is 1 meter, 2 meters or 10 meters or 100 meters. Here we are talking only about the length of the object. That is the reason why we call it as a scalar quantity. A physical quantity which is having only magnitude, that is what you call it as scalar. So when talking about the case of distance, you are talking about the total length of the path that is covered by an object. That is what you call it as distance. Then when talking about the term displacement, you are moving from point A to point B, right? You are moving from point A to point B. When you are moving from point A to point B through the path number 1, you are moving through point A to point B, the shortest distance. You are covering the shortest distance. At the same time, you are moving in a specific direction. Either you are moving towards the left hand side, or else either you are moving towards the right hand side, right? So that is what you call it as displacement. So here the displacement may be the shortest distance. The shortest distance may be 1 meter. At the same time, you need to specify some direction. You are moving towards the right hand side, right? You are specifying the direction, right side, maybe, or else your north side or east or west, whatever it is, right? Since you are specifying direction, since you are having certain amount of value, you call this one as a vector quantity. So displacement is the shortest distance that is covered by an object in a specified direction. That is what you call it as displacement. The units for this one again, meters. Distance and displacement both have the same units, right? Both are having the same units. Even though one is a scalar quantity, other one is a vector quantity, the units for these two will remain the same as meters, right? Then Moving on to the next one, that is the examples for displacement. Examples for displacement. So when talking about the case of examples for displacement, always remember that if at all the starting point and ending point both are same, if at all the starting point and ending point, starting point is equal to the ending point, in that particular case the displacement of an object is always equal to 0. In simple terms, the initial position and final position, if both are same, then in that particular case displacement of an object is equal to 0. Now for example, suppose that here in this particular case I am talking about a circle like this, right? Now here in this particular case you are starting at the point A. In a circular path, you are starting at the point A. You are starting at the point A, and after completing one rotation, again you are coming back to the same point A. So here in this particular case, the starting point as well as ending point both are same. The starting point and ending point both are same. So when starting point and ending point, or as the initial point and the final point both are same, then in that particular case the displacement that is covered by an object is always equal to 0. Right? Even though you are covering 10 rounds or 20 rounds or 100 rounds, then in that particular case the displacement covered by an object is equal to 0. But wherein when you are moving in a circular path like this, the distance that is covered, right? Distance, what is distance? The total length of the path. So when you are moving in a circular path, the distance that is covered is equal to perimeter of the circle. The circle of the circle, that's nothing but 2 pi r. So when you are moving in a circular path like this, the distance covered is equal to 2 pi r, but wherein the displacement is equal to 0. At the same time, suppose that you are moving in a semicircular path. Right? Suppose that you are moving in a semicircular path like this. So when you are moving in a semicircular path like this, right, you are starting at the point A and ending at the point B. So when you are moving in a semicircular path, the distance covered is nothing but the circumference of the semicircle, which is given by 2 pi r by 2. The distance that is covered is half of the circumference of the semicircle. At the same time, when you are moving here in this particular case, the displacement that is covered by the object is equal to twice the radius. So here the starting point and ending point both are different. That is the reason why here you are getting a value for the displacement that is equal to 2r. But whereas in the earlier case, when you're talking about a circular path, so in the case of circular path, when starting point as well as ending point both are same, you are starting at the point A and after completing one rotation again coming to the same point B. Here in this particular case, the point A is equal to B. In simple terms, starting point and ending point both are same. When starting point and ending point both are same, in that particular case displacement covered by an object is equal to 0, but distance is nothing but 2 pi r. Then moving on to the next example in the case of your displacement. Suppose that you're talking about the case of a simple pendulum. So whenever a simple pendulum is oscillating between two different points, right? This is a simple pendulum always executes a simple harmonic motion between two different points like this, right? This point or else this particular point, this is what you call it as the extreme points or the extreme positions, wherein this particular point is known as the mean point or the mean position. The simple harmonic motion, a pendulum is executing a simple harmonic motion between two different points, extreme point passing through the mean points. So whenever a pendulum is executing a simple harmonic motion, the displacement of this one is always equal to 0, because the pendulum is starting its journey at this particular point, reaching up to this particular point, and again coming back to the same point. That is the reason why here in this particular case displacement is equal to 0. And when talking about the term displacement, now this particular term displacement can have the values of this one. The displacement can have different values. The displacement of an object, displacement covered by an object can be positive. The displacement covered by an object can be negative also. At the same time, the displacement covered by an object can be equal to 0. right? Now we'll see how it is positive, how it is negative, and how it is zero. Then when you are moving from point A to point B, you are covering some certain amount of distance. Now this particular distance is something equal to 1 meter or 2 meters. This is nothing but basically a positive value. So displacement is positive. Whenever you are moving between two different points, any particular path, maybe two straight points or zigzag points or whatever it is, the displacement will be always a positive point. At the same time, suppose that you are moving in a circular path. When you are moving in a circular path, you are starting at this particular point, after making one complete round, again reaching the same point. So here in this particular case, initial point is equal to final point. In that particular case, the displacement of an object is equal to 0, right? So displacement can be positive, displacement can be 0, but when the displacement of an object will be negative. Now here, suppose that you take a tall building like this, a tall building which is having a height h, a tall building which is having a height h, right? From the top of a tower, starting at this particular point, tower or the building, from the top of the tower you throw an object in the upward direction. Now this particular object, after traveling, it just moves onto the ground in this particular way. This is the case of the ground, right? When the object is projected in the upward direction, this particular object is covering certain amount of distance in the upward direction. Let that particular distance be equal to something equal to x. Now here in this case, from where we are throwing the object? From this particular point, right? So what is the displacement of this object? From this particular point to this particular point, that is the displacement covered. So we'll measure how it is. So from here to here, this will be again equal to x. Since in the upward direction it is x, downward direction will also be equal to x. At the same time, from here to here, the value of this one is something equal to x. The displacement that is covered by an object equal to x. This is in the upward direction. You are throwing from this particular point, right? Therefore, up to this point, that is x. Then from here to here, from this particular point to again to the ground, that will be x plus h. But since this particular direction, this is in the reverse case, right? So here we take this value as minus. So as a result of which, if you simplify this one, you'll be getting the value of h as minus h, right? Indicating that the displacement that is covered by an object is something equal to minus h. So the displacement that is covered by an object can be positive. When it is positive, when you are moving in a straight line path, it is always positive, right? It can be 0 when it is 0 when you are moving in a circular path. If at all the initial point and the final point both are same, displacement is equal to 0, right? At the same time, when it is negative, whenever an object is projected from the top of a tower like this, in that particular case, the displacement that is covered by an object will be always negative, right? The different cases. Then after scalars and vectors, then we'll go on to the next one, that is the case of velocity of an object, right? Speed as well as velocity. Now we're talking about the case of speed. Now we all know that speed equals to, right, distance by time. Speed equals to distance by time. So when you're talking about the case of speed as well as velocity, speed, we all know the simple thing, speed equal to distance by time, and this particular distance, whatever quantity it is a scalar quantity. It is a scalar quantity, right? Distance is always a scalar quantity. Now coming to the case of velocity of an object. What is velocity? So velocity equals to displacement by time. The velocity of an object is equal to displacement, the ratio of displacement as well as time. That is what you call it as velocity. The units for both may be speed, at the same time velocity. The units for both is measured in terms of meter per second. The units will remain the same, but this particular quantity called as speed, right? This particular quantity called speed is a scalar quantity, but wherein velocity is a vector quantity. Speed is a scalar quantity, but wherein velocity is a vector quantity. Velocity is nothing but the change in displacement with respect to time, right? That is what you're calling it as velocity. And this particular velocity of an object, the velocity of an object can be two different cases. One is uniform velocity, the other one is non-uniform velocity. The last time in the case of SSC examination, one particular question was based on graphs. So here in the case of velocity, we'll try to see some graphs also, right? So when we're talking about the case of non-uniform velocity, first we'll see what is uniform velocity. What is uniform velocity? So when talking about the case of uniform velocity, we're talking about two different points. We're talking about two different points, the point A as well as the point B. Now this particular journey from the point A to the point B, you are dividing into some equal lengths, right? You are dividing this one into some equal lengths. This is B and this is C. Sorry, a small correction here. Right, this is C and this is D. Right, the length from A to C, this is 1 meter, from C to D 1 meter, from D to B 1 meter. If an object is covering, right, the distance of A to C, if an object is covering the distance from A to C, if an object is covering the distance from A to C in 1 second here, from C to D 1 second, from D to B 1 second. So here we observe that equal distances are covered in equal intervals of time. So whenever an object is covering equal distances in equal intervals of time, the distance from A to C is 1 meter, the time taken is 1 second. The distance for the case of non-uniform velocity. So again there in that particular case, we're talking about two different points, the point A as well as the point B. The point A as well as the point B. Now this particular journey from the point A to B, you divide this into some equal parts. You call this one as C, I call this one as D. The distance from A to C, the distance from A to C is 1 meter. The distance from C to D is 1 meter. From D to B is 1 meter. So if at all you are able to cover this particular 1 meter distance in 1 second here, A to C you are covering in 1 second, but C to D it is taking around 3 seconds of time, and D to B it is taking 5 seconds of time. So here what you are saying, we are saying that here in this particular case, equal distances are covered in unequal intervals of time, else the reverse way. So here in this particular case, so the distance from the point A to B is again divided into some equal parts, A to C and D to B, right? The length here, A to C, something I'm calling it as 1 meter. Here it is 3 meters, here it is 5 meters. But how much time you are taking to cover A to C? A to C you are just taking only 1 second. C to D only 1 second. D to B only 1 second. So here what you are doing? You are covering unequal distances in equal intervals of time. So whenever an object is covering unequal distances in equal intervals of time, or else whenever an object is covering equal distances in unequal intervals of time, that particular thing is known as non-uniform velocity. But whereas in the case of uniform velocity, you are covering equal distances in equal intervals of time. So this is what you're talking about velocity. Now remember that velocity is always a vector quantity for which the units are meter per second. Right? Speed, right? Speed also has the same units, that is meter per second, but speed is a scalar quantity, velocity is a vector quantity, right? Just a look at the things. Now when talking about the case of scalars, we have seen that scalar is a physical quantity which is having only magnitude, right, without any specific direction, but no specific direction. That is the thing which you are calling it as a scalar, right? Examples for scalar, you're talking about distance, time, speed, mass, area, volume. You can give n number, right? At the same time, vector quantity, a physical quantity which is having which has, if you see this word, which has both magnitude and specific direction. It is having magnitude as well as direction. That is the reason why you are calling it as a vector quantity. Examples of vectors: displacement, velocity, angular velocity, acceleration, force, magnetic intensity, current density, electrical intensity. Can give a lot, right? Then now we're talking about the case of displacement. Here we have seen that. What is displacement? The displacement of a particle. Displacement is a vector quantity. Displacement is always a vector quantity. At the same time, the shortest distance between the initial and final positions, this is what you call it as displacement. Shortest distance between initial and final points, at the same time the one which is having both magnitude and direction, that is what you are calling it as displacement. Now in the case of a semicircular path like this, right, distance is always equal to 2 pi r by 2, nothing but pi r, or else displacement is equal to 2r, twice the radius. In this particular case, here if you see this one, an object like this, distance covered is equal to 2h, displacement is equal to 0. For which one? This is the case for an object which you are throwing upwards. Whenever you throw an object in the upward direction, this is the starting point. The object is moving from this particular point, rising upwards, and then again coming back to the same initial point. Since the starting point and initial point both are same, displacement is equal to 0. At the same time, here in this particular case. Now, in this particular case, when the object is moving on an inclined surface, the object is placed here. When the object is placed on an inclined surface, it has to move from top to bottom. So in this particular case, distance and displacement both are equal. And when an object is projected from the top of a tower, distance is always equal to h plus 2x, but wherein displacement is minus h in that particular case. A small correction in the figure. It is minus h. Displacement is minus h here, negative value, but wherein distance covered is height of the building plus 2x. Then at the same time, now here we have seen that in this particular case, distance and displacement both are equal. So keeping this thing in mind, you can just make a note that distance and displacement, there is some relation between them. The value of distance will be always greater than equal to displacement. Either greater or else it will be equal to displacement. The value of the distance will be always either greater than displacement or else it will be equal to displacement, but distance is never less than displacement. Distance is never less than displacement. The value of distance is always either greater than displacement or else either it is equal to the case of displacement. Then when talking about the case of velocity, now we have seen that velocity, the ratio of displacement and time, that is what you are calling it as velocity. The units for that one is meters per second. Then uniform velocity. Now here this is the case of the graph which you are drawing for uniform velocity. Now in the case of uniform velocity, now here if an object is covering equal distances in equal intervals of time. If an object is covering equal distances in equal intervals of time. So there in that particular case, that is what you call it as uniform velocity. So here when trying to draw the graph, you draw a graph keeping in view time and velocity. Velocity is always taken on y-axis, time is always taken on x-axis. The reason for taking time on x-axis is that with respect to change in time, the velocity of an object is changing. With respect to change in time, the velocity of an object is changing. That is the reason why time is taken on x-axis and velocity is taken on y-axis. When you draw a graph between time and velocity, the graph is always a straight line. The graph is always a straight line parallel to x-axis. Since here in this particular case, the object is moving with uniform velocity, the velocity of the object is not changing. It's neither increasing nor decreasing, it's remaining uniform. That is the reason why the graph is always a straight line which is parallel to x-axis. At the same time, now suppose that you're talking about the case of non-uniform velocity. When you talk about the case of non-uniform velocity, so here in this particular case, the velocity of the object may be increasing or may be decreasing. Now when you draw a graph between time and velocity here, you see that the velocity of the object is decreasing here. With respect to time, it is decreasing. After a certain interval of time, again it is increasing, again decreasing, again increasing. So this is the nature of a graph which for an object which is moving with non-uniform velocity. The velocity may be either increasing or else the velocity may be either decreasing, right? Then one graph, you need to talk about one particular thing called as a graph of displacement and time, right? So we're drawing a graph between displacement and time. Again, time is always taken on x-axis, velocity is all displacement is always taken on y-axis. Displacement is always taken on y-axis, time is always taken on x-axis, because with respect to change in time, the object is changing its position. That is the reason why displacement is taken on y-axis, time is taken on x-axis. When you draw a graph for this one, the graph is always a straight line passing through the origin. The graph is always a straight line passing through the origin. Now for this particular thing here, with this word is important, slope, right? We're talking about the term slope. What do you mean by the term slope? Now in the case of your mathematics, we know that slope equals to y2 minus y1 by x2 minus x1. In simple terms, the gradients of y-axis by the gradients of x-axis. So here when you're talking in the case of the slope, you're talking about the y-axis terms. What we are taking on y-axis? We are taking displacements, right? S2 minus S1. The difference in S2 minus S1 divided by to the ratio of T2 minus T1. And displacement and time. What is displacement by time? Displacement by time is nothing but velocity. That is the reason why we say that the slope of displacement time graph will always give you velocity. At the same time, you're talking about one more thing, the slope of velocity and time graph. Suppose that you're talking about the slope of velocity and time graph. So it's not here. Right. Now here in this particular case, the slope of velocity and time graph on y-axis, what you are having on y-axis? We are having velocities v2 minus v1. At the same time, on x-axis, what we are having? T2 minus T1. The ratio of velocity and time, that will give you acceleration. The ratio of velocity and time will give you acceleration, right? So slope of velocity time graph will give you acceleration, slope of displacement time graph will give you velocity, right?